So question 11, we're being asked to find the exact values for cosine, secant, and tangent. We don't have to find the angle, just the values. So we're going to set up a triangle, and then we're going to use our definition of our trig functions to come up with the opposite over adjacent, those kind of things. So negative 5, 2 is over here. Here's negative 5, 2 would be something like this. So we set up our triangle. This is our, theta would be this angle, but measured from 0, right? We don't, but again, to kind of get the theta for this triangle, we're going to use this as our angle, this, reference angle if you want. But so this would be, we just need to label our sides. This is the adjacent side, this would be the opposite side, and this would be the hypotenuse side. Okay, so of this triangle, we're not looking at the top one, we're looking at the angle that is on the x-axis. Okay, so this is our theta. So that's how we label, this is a key part, labeling the sides, adjacent, opposite, and hypotenuse. So the adjacent side is where the negative 5 comes in. Again, the measure of the side is 5, but we will use negative 5 so that we get the right signs on our, because obviously cosines, because of where it's at, cosine's going to be negative. Cosecant is a 1 over sine, so it's going to be positive, and tangent's going to be negative because it's a negative and a positive in this quadrant. So kind of think about your signs, but notice everything will come together here. The opposite side is 2, and that's a positive 2. So if we keep that in mind, we're going to be fine. Now, since we've got tangent in there, we're going to need the hypotenuse. Oh wait, no, we don't need the hypotenuse for tangent. What we need it for is for cosine. So just kind of thinking of our triangle, a 5, a 2. This is going to be the square root of 5 squared plus 2 squared. All right, a squared plus b squared equals c squared. So we take its, this is our c. Take its square root. So that's going to be 25 plus 4, which is square root of 29. So c is square root of 29. That doesn't reduce, so that's what it is. What it is, square root of 29. So cosine is adjacent over hypotenuse. That's its definition. And I've had it here, but I haven't been pulling it up. Just remember the power of having this this formula sheet, and then putting all that you've thought about trigonometry in here at the beginning. Cosine is adjacent over hypotenuse. As I'm getting in about halfway through the exam, I'm starting to question myself. Which one is it? I put it down at the beginning when I was very clear. So this is the advantage of right before you take the test, have some basic things like this: cosine, sine, soca, toa. Work it so that the first thing you do is you put all these notes here, so you have them to refer back to. Okay, cosine's adjacent over hypotenuse, and then it's going to help me when we got cosecant, because I forgot what that is. What? Oh, it's 1 over sine, so I get the sine and then I reciprocate it. Okay, adjacent over hypotenuse. So the adjacent side is a negative 5. The hypotenuse is square root of 29. And that's what it is. So we put that in there. Okay, cosecant. Now to do cosecant of theta, what I'm first going to do is remember that's 1 over the sine of theta. So that's that definition. What is sine theta? Well, that's 1 over sine theta is opposite over hypotenuse, OPP over the hypotenuse. So what is that? Opposite is 2, positive. And hypotenuse is square root of 29. And so remember, you just take the reciprocal, square root of 29 over 2. If you didn't remember, it's 1 divided by 2 Square root of 29. To do this, we flip the second fraction, invert and multiply, right? 1 times square root of 29 over 2, which is just square root of 29 over 2. Okay, that's cosecant. There we go. And now tangent's going to be the easier one, I guess, because actually they gave us all the information at the start. We could have done that one easy. So tangent, right? Opposite over adjacent, the y over the x. So the tan of theta is going to be 2 over -5. But remember those signs, because tangent in the second quadrant has to be negative. So that's another way. We get our fraction 2 over -5. Well, I'm going to put the negative out front. It looks a little nicer. You could probably, leave it in the 5. That would be fine. But there we go. That's number 11.